There's some concepts in science, physics especially, where you just kind of nod along.
Oh, absolutely.
For me, spin was always high on that list.
Yeah.
You ask what it is, and, well, you get intrinsic quantum property.
Right. Standard answer.
Yeah, standard. But what does that actually tell you? I always felt like some, I don't know, weird-ass invisible tag stuck on particles.
That's a good way to put it. It's a label, definitely, but the what behind it feels, abstract, like you said, almost magical.
Exactly. So today we're doing a deep dive. We're going to try and pull back the curtain on spin.
Okay.
But not with the usual script. We're looking at it through a really interesting alternative lens, motion theory.
Ah, motion theory.
Yeah, and it's not just about spin. This theory sort of reimagines time, gravity, forces, what particles even are, all based on motion.
It's a fundamental rethink, looking at everything as arising from motion itself.
So think of this as, well, maybe a way to get a clear, maybe even intuitive handle on something usually kept under lock and key.
And that's the promise, isn't it? Moving past those vague descriptions, seeing spin as something that happens, something active, not just a static label.
That's the idea. Hopefully by the end, spin won't seem like quantum weirdness anymore, but something fundamental playing out everywhere.
Yeah.
Might even have a few aha moments.
Let's hope so.
Okay, so let's jump right in. Motion theory. Basic idea. What is spin, according to this view?
Right. So in motion theory, spin is essentially structured motion looping back into itself.
Structured motion looping. Okay.
Yeah. So instead of thinking of an electron as just a tiny point, imagine it more like a self-sustaining vortex or a pulse of motion, constantly cycling, reinforcing its own pattern.
A vortex is like a tiny rhythmic loop.
Exactly. That loop, that self-contained structured motion, that's the core idea of spin here.
Okay, so not a property added on, but the motion itself. It's literal movement, structured, looping back. Got it. But why? Why does it loop?
Ah, good question. The theory suggests it comes down to something called stability under constraint.
Stability under constraint.
Yeah, think about water going down a drain.
Okay.
The drain itself, the edges, they constrain the water's flow, right? And what happens? It settles into a stable swirl, a vortex.
Right, it has nowhere else to go, so it circles.
Precisely. Or planets orbiting a star. Gravity constrains their motion, and they settle into stable orbits, these huge loops.
Okay, I see the pattern. Constraints leading to loops.
So similarly, a particle like an electron exists in an environment. There are forces, fields, other particles, constraints, and its inherent motion settles into the most stable form possible under those constraints.
Which is a loop.
Which is a tight, self-reinforcing loop. So the constraints don't just limit it, they actually create this stable, ordered structure, like riverbanks guiding a flow.
Huh. So the motion makes the loop stabilizes the motion. Well, it sounds very mechanical.
It is. It's presented as a mechanical process, not particle magic.
A definite shift from the usual quantum talk.
And the really fascinating part is that motion theory argues this isn't just happening at the quantum level. This looping, this spin for stability, it's supposedly happening everywhere, at all scales.
Okay, that's kind of mind-bending. All scales. Give me some examples. How does this structured loop idea show up bigger?
All right, let's start small with the electron again. In this view, its spin isn't just in the atom, it actually forms the outer stabilization loop of the atom.
The outer loop. So it kind of holds the atom's identity together.
In a way, yes. It locks the atom's whole structure of motion into a stable, identifiable pattern.
Wow. Okay, so the electron spin is critical to what an atom is.
Exactly. Then zoom out slightly. The atom itself, the combined loops of its electrons, the nucleus, they create these overall atomic rhythms. That's the basis for all matter.
Okay, electron loops, atomic rhythms. Now go bigger. Something we can, actually relate to.
Our planet, Earth's rotation.
Our day and night cycle.
Yep. Motion theory sees that rotation as a massive structured motion loop. And it's not just about day and night. It's crucial for stabilizing the whole global system, weather, climate, even biological rhythms.
So Earth spinning isn't just spinning. It's a planetary scale stabilizer.
Yes.
That's a different way to think about it.
It keeps going bigger, too.
Galaxies.
Entire galaxies. They rotate, right? These huge spirals. Motion theory suggests that galactic spin is what holds those billions of stars together in a coherent structure. It's a cosmic scale synchronization loop.
Preventing everything from just flying apart into space.
That's the idea.
Yeah.
So from the tiny scale to the absolutely vast, spin as a structured loop is proposed as the universe's fundamental way to create and maintain stable structures.
This is a remarkably unified picture. Spin isn't just one weird quantum thing. It's the stabilizing principle.
That's the core argument, stability through looped motion. But it's not just stability, it's also about identity.
Identity. How does spin give something identity? Like, if you have two particles, same mass,
Yeah.
what makes them different?
Their spin. Even with the same amount of structured motion, what we call mass, the way that motion loops, the specific rhythm and pattern of the spin, can be unique.
A kind of motion fingerprint.
Exactly, a spin signature that differentiates particle types.
And this connects to things like fermions and bosons. Those half-integer spin things that always seemed, frankly, arbitrary.
It aims to explain them, yes. Fermions, electrons, protons have this half-integer spin. Motion theory interprets this as meaning their motion loop needs 2 full rotations, 720 degrees, to get back to its starting state.
2 full turns.
Whereas bosons like photons have integer spin, 1 rotation, 360 degrees, and their loop resets. So the difference in how they behave, how they interact, isn't some random quantum rule, according to this theory. It's down to the complexity of their specific spin dance.
Like one dancer needs a more complex move to complete their pattern than another.
Something like that, yeah. A boson's loop is simpler, resets easily. A fermion's is more intricate, takes that double turn. And this affects how they can synchronize or interact with other particles.
So it's the mechanics of the loops, not just abstract rules. And these loops, these signatures, they provide the stability, the anchor, keeping things from just dissolving.
That's the idea.
Yeah.
Without these stable spin loops holding their structured motion together, particles couldn't exist, atoms couldn't form, galaxies wouldn't hold their shape.
Okay. Now, what about charge and magnetism? They always feel linked to spin somehow. How does motion theory connect those dots?
Right, this is where it gets really integrated. The theory suggests spin isn't just internal. The looping motion creates effects that radiate outwards.
Ripples.
Kind of, yeah. Ripples or gradients in the surrounding motion field, if you like. These outward effects, these redistribution gradients, influence other nearby particles. And that's what we perceive as charge and magnetism.
Wait, so charge isn't a separate thing particles have. It's an effect of their spin.
It's proposed as an effect, yes. Essentially, charge is seen as a kind of motion imbalance that arises from how different spins align or misalign when particles interact.
An imbalance.
Okay.
And magnetism.
Magnetism is seen as a collective effect. When the spins of many particles in a material align, they create larger, stable, external loops of structured motion. These larger loops then exert influence on other magnetic materials.
So magnets attracting or repelling. And it's literally the spin loops in one magnet interacting with the spin loops in the other, based on their alignment.
That's the interpretation. Clockwise versus counterclockwise spins at the atomic level lead to different synchronization patterns. If the loops align constructively, reinforcing stability, you get attraction.
And if they clash, disrupt each other.
Repulsion. So in this view, spin is the underlying logic, the synchronization mechanism behind all those electromagnetic forces.
Yeah. It really does try to tie everything back to this core idea of looped motion. Okay, we've gone from tiny particles to galaxies, forces. Let's bring it home. Why should someone listening right now, care about electron spin loops? How does it connect to us?
Well, it connects quite profoundly, actually, because if this model is right, if those electron spin loops suddenly just stopped, unraveled, every atom in your body would disintegrate. Instantly.
Okay, and that's direct.
The stability of atoms, which allows for chemistry, which allows for biology, which allows for you, it all rests on these fundamental loops remaining stable. Without spin, as described here, matter as we know it couldn't exist.
So the very atoms I'm made of are held together by this spinning.
That's the claim. But it might go deeper. Motion theory even speculates about consciousness.
Consciousness? How?
Well, perhaps your thoughts are, in essence, incredibly complex patterns of synchronized neural loops in your brain. Structured motion looping.
Neural loops, okay.
Your heartbeat, a clear biological loop maintaining rhythm, stability, even your memories, your sense of self. Could these be stored, structured motion patterns, stable loops in your neural architecture?
That's a huge leap, from electron spin to my identity.
It's speculative, of course, but it shows the potential reach of the core idea, that loops of motion create stable structures and identities, from the physical to maybe even the mental. It's humbling, isn't it? How much relies on these unseen dynamics?
It really is.
Yeah.
So it's not just physics out there. It's, well, according to this, it's why I exist, why I can think these thoughts. That makes it pretty relevant.
That's the connection, yes. Spin isn't just some footnote in a textbook. It's woven into the fabric of your being.
Okay. Let's circle back then. Traditional quantum physics calls spin intrinsic, maybe unknowable at some level.
Mhm.
How does motion theory respond to that mystery aspect?
It basically says the mystery isn't inherent in spin. It argues spin is knowable, measurable. The difficulty, it suggests, comes from trying to understand it using models that don't fully grasp the underlying nature of structured motion itself.
So if you think of particles as just tiny balls, spin has to look weird and intrinsic.
Pretty much. You have no mechanism for it, so it just is. But if you start from the idea that a particle is a specific pattern of looped motion, then spin becomes, well, just a natural description of that motion.
Like asking why a vortex spins. It spins because it is a vortex.
Exactly. So the perceived mystery might stem from the limitations of the older models, not from spin itself.
And by seeing particles as these dynamic loops, maybe other quantum weirdness starts to make more sense too, like entanglement.
That's the hope. Things like entanglement, superposition, uncertainty. Motion theory suggests they become clearer when you see spin as dynamic motion responding predictably to synchronization constraints. The weirdness fades when you have a more mechanical picture.
Okay, let's tackle entanglement.
Yeah.
The classic spooky action at a distance. How does spin as a loop demystify that?
Well, motion theory rejects the spooky action idea entirely. It proposes entanglement is really extended structured motion synchronization.
Extended synchronization, meaning?
Meaning instead of two separate particles somehow linked mysteriously, think of them as sharing one single continuous structured motion loop that's just stretched out across space.
One loop connecting both, like two beads on the same string.
A bit like that, yeah. Or two connected pendulums. They're part of the same system, so they aren't sending signals back and forth.
Ah, so measuring one particle's spin instantly tells you the others because they're just two parts of the same motion pattern?
Precisely. You're not influencing something far away. You're defining the state of the single system they both belong to. No faster-than-light communication needed. It's just fundamental interconnectedness through motion.
That actually sounds much less spooky. A single system across space.
Okay. It reframes entanglement as a natural consequence of how motion organizes itself, suggesting a deep underlying unity.
Right. And you called spin the universal structure-building mechanic earlier. Can you layer in a few more examples of that just to really hammer home how pervasive this idea is in the theory?
Sure. We touched on quarks and gluons spinning to form protons and neutrons. Then electron spin loops creating atomic shells, which define all of chemistry.
How elements bond, react.
Exactly. Then atoms combine, their various spin loops nest and synchronize to form stable molecules with specific shapes and properties.
Oh,
Think even about DNA, that double helix. Could that be seen as a kind of helical spin-like loop storing information?
a biological information loop. Interesting.
Then back to the large scale. Planetary spin stabilizing orbits and climate, galactic spin organizing stars. It's presented as the same fundamental principle, looped structured motion, creating stability and form operating everywhere.
Nature's go-to building block, essentially. Using loops.
That's the picture it paints, yes. A universe built on motion loops.
Okay, if this understanding of spin, this mechanical view, is even partially correct, what about technology? You mentioned possibilities.
Right. A real grasp of spin as structured motion could theoretically open doors, like spintronics.
Spintronics.
Yeah. Computing using electron spin directly, not just their charge. Encoding information in the up or down of the spin.
What would that mean? Faster computers.
Potentially much faster, yeah. And much lower energy use. Maybe even non-volatile memory data stays even when the power's off. That'd be huge.
Wow, okay. That alone is transformative. What else?
Material science. Understanding electron spin synchronization might be key to designing room temperature superconductors.
Zero resistance electricity flow at normal temperatures.
Yeah.
That would change everything. Energy grids, electronics.
Absolutely. Then, more speculatively, maybe advanced propulsion. If we could somehow harness or manipulate large-scale spin loops, could that interact with gravity, offer new ways to move?
That sounds like science fiction, but rooted in the theory, I guess.
It's way out there, but it follows the logic. And finally, quantum computing. Understanding spin synchronization better could be crucial for building stable, reliable quantum computers.
So controlling those quantum bits, the spins, more predictably.
Exactly. So these aren't just abstract physics ideas. They could lead to very real technologies if the theory holds up and we can engineer based on it.
It really bridges that gap between fundamental theory and tangible application. A future where we engineer based on motion loops.
That's the potential. And beyond technology, this perspective, this focus on spin as looped motion, might eventually connect fields like biology, neuroscience, cosmology. seeing the same fundamental pattern at work.
Like a unified principle cropping up everywhere.
Maybe. Imagine future students starting not with static particles, but with structured motion loops, making spin intuitive from day one.
That would certainly change how we learn physics.
It would change how we see the universe.
Okay, as we wrap this up, what's the one big takeaway? If someone remembers just one thing about spin from this motion theory perspective, what should it be?
I'd say, let go of the weirdness. See spin not as magic, but as something beautiful and fundamental. Structured motion in a stable, self-reinforcing loop.
Motion looping back on itself.
Exactly. And realize that this simple-sounding idea has huge consequences, from particles to galaxies to you.
Right. It's not just out there. We are these spinning systems, in a way.
Absolutely. Every atom, every heartbeat, maybe every thought, underpinned by these loops. You're an incredibly complex system of nested, spinning, structured motion.
So maybe that feeling of spin being weird wasn't about spin at all. Maybe it was about us not having the right way to look at it yet.
That's a great way to put it. Understanding spin, in this view, isn't just decoding physics. It's maybe, just maybe, starting to decode ourselves and our connection to everything else.
A lot to chew on there, thank you.
Yeah.
This has definitely shed a very different and surprisingly intuitive light on spin.